So we're starting to build a picture of the definition of our function values for any point traveling around a circle. We have special, ideas or maybe a better image happening for our quadrantal values. And now let's talk about when we are thinking about the signs and the ranges of these particular function values. We're going to focus right now on just the signs of those values as it moves around the unit circle or around the quadrants. And there is a great acronym to help us remember when a certain or which function values are positive in which quadrants and which ones are negative. So in the first quadrant, what we have are all function values are going to be positive. So if I were to take the sine of something, let's say I have an angle 30 degrees, because that would fall in the first quadrant, and if I were to find the 6 function values for 30 degrees, every single one of those values would end up being positive. If I move off to the second quadrant, in the second quadrant we would have an angle such as maybe 120 degrees. Well, if I'm in the second quadrant, only sine and its reciprocal cosecant are positive there, and the remaining 4 function values are going to be negative. If we look at the third quadrant, so in the third quadrant we might have an angle of, let's say, 200 degrees. At 200 degrees, only tangent and its reciprocal are positive, and the remaining 4, sine, cosecant, cosine, and secant, would be negative. And then finally, if we get to the fourth quadrant at, say, some angle maybe 307 degrees, only cosine and secant are positive, and the remaining 4 would be negative. So how do you remember that? There's this little phrase that says, all students take calculus, and as we are moving positively, remember, if I move positively, then I'm going counterclockwise around the circle. So or the quadrants, as I move counterclockwise and enter into these different quadrants, all students, so if I'm in the first quadrant, everything is positive. Students, representing the second quadrant, says that only sine and cosecant are positive. Take would be the third quadrant. That stands for tangent, cotangent. And in the fourth quadrant, calculus stands for cosine and its reciprocal secant. So all students take calculus helps us identify which functions are positive, and then we fill in which ones would therefore have to be negative. So let's practice that for just a second. If I've got these examples over here and I want to figure out, I just want to know what the sign of the function values are given 73 degrees. So if I'm thinking 73 degrees would be over here in the first quadrant. And in the first quadrant, all functions are positive. So let's move on to B. 303 degrees. So 303 degrees falls down here in the fourth quadrant. So only cosine and secant are positive, and then sine, cosecant, if I can write it, sine, cosecant, tangent, and cotangent would be negative. So we'll finish this off by looking at this last one at negative 200. If I rotate negative 200 degrees, where will I land? Well, negative 200 degrees says that I'm going to be rotating more than 180, but stopping right there. I haven't gone fully to 270. I am in between 180 and 270, which means I have to have ended in the second quadrant. When I'm in the second quadrant, sine and cosecant are positive. The remaining 4, cosine, secant, tangent, cotangent, are negative. So you can see that that acronym, all students take calculus, helps us determine what the sign, positive versus negative, is going to be depending on what quadrant I've landed in. And the reason that that becomes important is because as we start to understand and maybe memorize the function values as we move around these 4 quadrants, we're going to see that they kind of get repeating. They start to repeat in number. The only way they differ has to do with that positive versus negative. So let's look at this idea here, this last example. Suppose now that we have an angle theta that falls in quadrant 2, and the sine of that angle ends up being 2/3. So the function value of theta for the sine of theta ends up being 2/3. So let's see if we can figure out what the 5 remaining values would be. So we have here, we have some angle theta that's over in the second quadrant. And we know the sine of that angle is equal to 2/3. So if I know that the sine of theta is 2/3, let's use the definition of sine then to figure out and break this apart into its x, y, and r components. Sine was defined as y over r. So this tells me then that y has to be 2, r is 3, and I'm missing x. So I can solve the Pythagorean theorem for the missing value of x. So if the Pythagorean theorem is listed as x squared plus y squared is equal to r squared, I'm interested in isolating x. I'm going to subtract r squared to the right. X squared would be, or not r squared, I'm going to subtract y squared. And then I'm going to take the square root of both sides. And I find out x is equal to the square root of r squared minus y squared. Now when I take the square root, we normally have both a positive and a negative solution. So how do I know which one to use? Do I use the positive or do I use the negative? Well, that's where knowing what quadrant theta is in helps me determine what values I need to come up with for my x's, y's, and r's. So if theta is over in the second quadrant, y is going to be positive, but all of my x values are going to be negative. So we're going to take the negative value of this. So when I replace in here the numbers that I'm looking for, so I've got the square root of 3 squared minus 2 squared. So 3 squared is 9 minus 2 squared, which would be 4. So 9 minus 4 would be the square root of 5, and I know that this is negative. So we need to figure out what cosine of theta is. Cosine is x over r, or negative square root of 5 over 3. Tangent of theta would be y over x, so that would be 2 over negative square roots of 5. Can't leave square root of 5 in the denominator, so we're going to multiply top and bottom by the square root of 5. That's going to give me 2 square roots of 5 over 5, and that is negative, before I forget. Then we move on and we look at, let's see, we have sine, so we're going to go with cosecant of theta. Cosecant of theta would be y over r, or not y over r over y, which would be 3/2. Secant of theta would be r over x, or 3 over negative square roots of 5. When I rationalize the denominator here, I end up with negative 5, no wait, brain and mouth are not working, negative 3 square roots of 5 over 5, and then we have cotangent of theta, which would be x over y, or negative square root of 5 over y, which would be 2. So we have cosine, which ends up being negative 5 square roots of 3. We have tangent, which is negative 2 square roots of 5 over 5. We have cosecant, which is 3/2, secant, which is negative 3 square roots of 5 over 5, and cotangent, which is negative square root of 5 over 2. That's a mouthful to say, but if I want to go back and at this point just check my work and make sure I did it right, I should be able to quickly scan through here and verify, first of all, that I have the signs right. Because I'm in the second quadrant, only sine and cosecant should be positive, in which case they are here, and everything else should be negative. So that's one thing that I want to make sure I check.